Now that we have a better idea of the different ways we can prove congruent triangles, let's look at some examples. ABC is an equilateral triangle. D lies on BC. AD is perpendicular to CB. Prove that triangle ACD is congruent to triangle ABD. Now, in our introductory video, we looked at separate triangles, but in the examples you will see in this course, both triangles will be included in the same diagram. So a good place to start is to highlight the two triangles we need to consider. So let's make triangle ACD red and make a note that this is triangle ACD. Let's make triangle ABD blue and make a note of triangle ABD. Now, there are four possible reasons that we can use to prove congruent triangles. Let's write them at the top of the page. We can prove 3 pairs of equal sides, and we use the reason SSS. We can prove 2 pairs of equal sides as well as an included angle, and we use the reason SAS. We can prove 2 pairs of equal angles and 1 pair of equal sides and use the reason AAS. Or if we have right angle triangles, we can use RHS for right angle hypotenuse side. Now we can consider our triangle, make our statements, and give our reasons. When considering two triangles, it is always a good idea to start with the information we've been given. Now, the question tells us that ABC is an equilateral triangle. We know from our work with triangles that an equilateral triangle has 3 equal sides. So in this case, AB is equal to BC, which is equal to AC. A and C are the first 2 letters in triangle ACD. A and B are the first 2 letters in triangle ABD. So these are corresponding sides. So we can make the statement that AC is equal to AB. We know that this is true because ABC is an equilateral triangle. When writing equilateral triangle as a reason, you don't have to write down the whole word equilateral. You can write the first few letters as we have done here with equi followed by the triangle symbol. We know that ABC is an equilateral triangle because this has been given to us in the question. So we include given as our reason. AB is equal to AC. So let's mark this corresponding pair of equal sides on our diagram over here. The question also tells us that AD is perpendicular to CB. Perpendicular lines create 90-degree angles, and we can see this from the 90-degree angle in our diagram over here at D. Now, D is the last letter in triangle ACD and the last letter in triangle ABD. So these are corresponding angles. AD is perpendicular to BC. These are 2 straight lines that create 90-degree angles, which means that if angle D on this side is 90 degrees, then angle D on this side is also 90 degrees. Now we can make our statements, but make sure that you are specific when referring to an angle. In triangle ACD, angle D is actually angle ADC. So we can say angle ADC is equal to, in triangle ABD, angle D is actually angle ADB. And we know that both of these angles are equal to 90 degrees. As our reason, we can say that AD is perpendicular to CB. And we know that this is true because this information has been given to us in the question. Now let's have a look at the possible reasons at the top of the page. We have just found one pair of corresponding sides that are equal and one pair of corresponding angles that are equal. We have an angle and a side, so we are not going to use three equal sides as a possible reason. So let's take SSS out of our list. Our angle is the 90-degree angle at D. AB is the hypotenuse in triangle ABD, and AC is the hypotenuse in triangle ACD. So if we can find another pair of sides, we can use RHS as a reason, because now we have the hypotenuse. This means that we can't use SAS. So let's take this reason out of our list as well. And now we need to find one more angle or one more side, but we don't have enough information to find angle A, angle B, or angle C. So we cannot find another angle. So let's remove AAS from our list of possible reasons. This means we have to find another pair of sides. We don't have enough information about sides BD or DC, so we cannot use these. But we do have AD. Now we have highlighted AD in red and in blue because AD is a side in both triangles. In ABD, A is the first letter and D is the third. In triangle ACD, A is the first letter and D is the third. So AD is the corresponding side in both triangles. When we worked with similar triangles, we said that if an angle appeared in two triangles, we could consider it as a corresponding angle because the size doesn't change. We can apply that rule here as well. AD in triangle ABD is the same size as AD in triangle ACD. So we can say that AD is equal to AD. And as our reason, we use common. Now we have a pair of corresponding 90-degree angles and two pairs of corresponding sides that are equal, and they include the hypotenuse of each triangle. So we have enough information to prove that these two triangles are congruent. So we can say triangle ACD is congruent to triangle ABD, and as our reason, we use RHS for right angle hypotenuse side.